All right, so this kind of thing is going to happen a lot, especially with estimating proportions where we have a ridiculously huge sample size that's just not going to be reasonable. And we need to figure out how to shrink that. So first off, I want to just quickly explain what's happening here, because with means, we'll commonly get sample sizes where in order to guarantee that we're going to get a good confidence interval, I could get sample sizes less than 100. But for confidence intervals for proportions, I'm commonly going to need hundreds or thousands of observations. And this really all goes back to week 1, when we started talking about levels of measurement, where each step up the level of measurement gave us more information and enabled us to do more kinds of arithmetic with it. So that river depths example that I gave for finding minimum sample sizes for a mean, the river depths that we record are ratio level data. That's like the best kind of data, and it's the most information. Best kind of data meaning I can do the most things with it in terms of statistical analysis. And it's the most information I could have about something, right? It's certainly better than saying deep or not deep, right? Which would be basically like having an iPhone or not having an iPhone. That's just categorical data, and at its worst, it's nominal level. And when I say worst, I mean just the least amount of information I could have, and least amount of stuff I can do with it. So when I have so much less information per observation, I am going to need to gather a lot more data. So we should expect to get these very large sample sizes when we're doing categorical stuff. But even with the river depths example, when I only needed like 35, well, driving out to all these crazy rural places trying to measure river depths may also be itself very irritating to have to deal with. And so we may want to figure out how to shrink that if even 35 is kind of an unreasonable amount of measurements that we need to take. So there's two things I can do regardless of whether I'm doing a mean or a proportion in order to shrink that minimum sample size. So there were really two things that we set there: our confidence level and our allowed margin of error. Well, if I allow my margin of error to be bigger, I don't need to gather so much data, right? I don't need to be, if I don't need to be so precise, I don't need so much information to get me within that margin of error. So one thing I could do is just increase the margin of error. Another thing I could do is change my confidence level. So I used a 99% confidence level for that iPhone example. And if I could just drop that to 95%, right, so that instead of being right 99% of the time, I'm right 95% of the time, that's still very good. I will be able to shrink that confidence, or I'll be able to shrink the minimum sample size to achieve that confidence interval that I need. So let me just quickly show you what actually would happen here. So I found that I needed over 4,000 observations to get the percentage of iPhone users to be within 2 percentage points. So let me just go back and up that to, right, the tiniest little bit. We'll change it to 3 percentage points instead of 2. And I'll just drop that 99 to 95%. Let's see if that makes much difference. It made a huge difference, right? It went from 4,000 to 1,000. That's huge. That's huge. All right, I dropped it by 75% by making a very, very small adjustment to where I don't think that realistically in any practical use of this, it wouldn't make any difference. So those are the two things we need to be able to change in order to shrink these required minimum sample sizes. Either 1, increase our allowed margin of error, or 2, decrease our confidence level.